Hello everyone, today we'll be doing a problem from David Morin's mechanics about a block sliding down an inclined plane. Right, so let's read it. A block slides down a frictionless plane from the point 0, y, so the y coordinates given, to the point b0, so somewhere here, where b, the distance b, is going to be given. For what value of y does the journey take the shortest time, and what is this time? So let's say this angle here is going to be theta, and we know that tangent theta is simply the opposite over adjacent, which is going to be y over b. Right, and say we have a block here, so very standard force analysis. This is going to be its weight, mg, and we can split the weight into components. The weight of the component that causes the acceleration is going to be mg sine theta, and your normal force is going to be mg cosine theta. Again, very standard analysis, and when we apply F equals to ma, we see that the acceleration is going to be given by g sine theta. So we want to find a certain time, and they ask what is this time, and obviously it would be really good if you thought of the kinematics equations of motion, right, which we can use. So in this case, the distance that it's going to have to traverse here, we can just use Pythagoras theorem, which is simply b squared plus y squared. So when we apply s equals ut plus half at squared, I get root of b squared plus y squared equals u is 0 because it starts at 0 meters per second. So I'll get half times acceleration g sine theta times t squared. So obviously I can solve this for my t squared. Right, if I multiply by 2 on both sides, it will be 2 root b squared plus y squared over g sine theta. But now there's a bit of a problem, because it asks for what value of y does the journey take the shortest time. We don't exactly know that. So we could either write sine theta in terms of y, which is very possible, right? By the trigonometric identity, we can also find that sine theta is going to be opposite over hypotenuse, which is y over y squared plus b squared, but we would have to do some differentiation there to find your dt over dy, and that's going to take us quite some time. Instead, a shortcut for this is to write root b squared plus y squared into a trigonometric function, and then solve for the minimum t squared. And what function is the most convenient is actually cosine theta, because cosine theta is b over y squared plus b squared, and b here is a constant that's given to us, so it's better for calculations. So we can simplify this into 2, and root b squared plus y squared is simply b over cosine theta. It's going to be over g sine theta. We can simplify this. Alright, so it becomes 2b over g sine theta cosine theta, which is 2b over g over 2 sine 2 theta. I've used trigonometric formulas, which will give us 4b over g sine 2 theta. That's our time. And we want to find the shortest time, which will occur when we maximize the denominator. In other words, sine 2 theta is maximized when it equals to 1, or 2 theta equals to 90, or theta equals to 45. And this means, from very simple geometry, you can see that y, this distance, is going to be equal to b. So we get this condition for y, and we've solved the first part of this question. So y equals to b, right? We can deduce here. So when y equals to b, my t minimum, right, this is actually t squared. So my t minimum, I have to take the root, which is 4b over g sine 2 times 45, which is simply 4b over g. This sine 90 is 1, and this is 2 root b over g. So we've found an expression for the minimum time. Next, the harder variation to this problem is that there's now going to be a coefficient of kinetic friction mu between the block and the plane. So our new acceleration, if we want to do F equals to ma, so that is this frictional force Ff, which is mu n, which is simply mu times mg cosine theta. Right, so the F equals to ma equation for part 2 becomes that mg sine of theta minus mu mg cosine of theta is ma. So a is g sine theta minus mu g cos theta. Right, and of course my suvat is going to be a bit more complicated now. Right, so S, so it's still the same, right? You see that b squared plus y squared is going to be half at squared. Then we'll get that t squared is 2 root b squared plus y squared over g times sine theta minus mu cos theta. B squared plus y squared is nothing more than b over cosine theta. So we can simplify this. It becomes b. This becomes times cosine theta in the denominator, right? So which is 2b over g sine theta cosine theta minus mu cosine squared theta. So what we want to find is the minimum value of my time t, right? So the graph maybe will look something like this. The t and theta graph. So I want to find the minimum value, meaning that I want to differentiate, right? Dt over d theta, and of course this, right, when t is at a minimum, this expression over here will have to be at its maximum. So we can simply differentiate, right? It's not much said, right? So d over d theta of this whole expression and we have to set it to equal to 0, right? Because the graph will look something like this, right? Where we have a sum with theta value. Perhaps it will start off like this, go like this, and like this. So we have to take the derivative and set it to 0 to find the maximum. What we'll get is that g is simply a constant. I don't really need to care about that when I'm setting it to 0. But but for this term over here, we can use the product rule, right? So it'll be sine theta. Derivative of cos theta is negative sine theta, plus derivative of sine, which is cos theta, and I keep my cos theta, minus, it's going to be mu which is a constant, and cos squared theta is actually cosine theta to the power of 2. So if you were thinking that I can differentiate this by just writing negative sine theta squared, which is sine squared theta, that's unfortunately wrong. Right? You're gonna have to use the chain rule for this. And the chain rule states that you have to bring this power here and differentiate the inside. So it's pretty standard, so this becomes cosine theta. Right, the power here is 1, just cosine theta, it's by itself, and then differentiate cosine theta, which is negative sine theta. Oh, sorry, this should be 2. It should be 2 cosine theta. Right, because my power is 2, and I move it here. So I'm setting this equals to 0. Let's simplify. I actually have cosine squared theta minus sine squared theta minus, so plus, minus is plus 2 mu sine theta cosine theta equals 0. I see that I can simplify this into cosine 2 theta. It's just a formula. 2 sine theta cosine theta is sine 2 theta times mu equals 0. Right. Right now I actually want a formula for the angle, right? Because I need to know what this angle is in terms of mu, so I can sub it all in later. So when we simplify, let us divide throughout by cosine 2 theta. So it'll be 1 plus mu tangent 2 theta equals 0. Get that mu tangent 2 theta is minus 1. Tangent 2 theta is negative 1 over mu. Okay, so we have this relationship, right? And right now, because this coefficient of friction is actually varying, so this causes the angle that we need for the T minimum to vary also. But at the end of the day, it all depends on this coefficient of friction here. So we want to, I'll copy and paste this expression for T squared. We'll just paste it right over here. Right, we want to write all of this in terms of mu. But right now I only have tangent 2 theta. I don't have... Okay, we can simplify this to sine 2 theta. We can simplify this to cos 2 theta also, because there are formulas for this. So right now what we can do is that we can do the trigonometric, we can infer the values of sine 2 theta and cosine 2 theta from this. Because this is your quadrant. And I know that theta is ranging from 0 to 90 degrees. So 2 theta has to be 0 degrees to 180 degrees. So we're dealing with the first two quadrants. And coefficient of friction is always positive, meaning that negative 1 over mu, it has to be negative. Meaning that, because it's ASTC, tangent negative is in the second quadrant. And the very interesting thing about this, right, is that, for example, this is going to be 2 theta, and the tangent is just opposite over adjacent. It's opposite over adjacent. The very interesting thing about this is that it reveals to us that 2 theta is actually in the second quadrant, which is 90 to 180 degrees, meaning that theta has to be 45 degrees to 90 degrees. So meaning that when there is some sort of frictional force, my angle that I need, instead of theta equals 45, my angle will actually increase. Right? It'll increase to look something like this. So it doesn't decrease, but it increases. So that's what it basically tells us. So of course now we can work out the whole trig, the trig values, right? Because the hypotenuse here is just root mu squared plus 1. So I know that sine of 2 theta, right, it's is opposite over hypotenuse, so it's 1 over mu squared plus 1. Cosine 2 theta is adjacent over hypotenuse. Actually, for simplicity's sake, let's just denote this value here, 1 over mu squared plus 1 as alpha. Just call this alpha. So this becomes negative mu alpha. Right. Let's write this here also. And we are basically very close to the solution already. Right, this is simply 2b over g over 2 sine 2 theta negative. Okay, we have to find out what's cos squared theta. And if you remember this formula, that your cosine 2 theta is actually cosine squared theta minus sine squared theta, which is cosine squared theta minus 1 minus cosine squared theta, which is simplified to 2 cosine squared theta minus 1. Then you can find out what's cosine squared theta. Right, so negative mu alpha is 2 cosine squared theta minus 1. Cosine squared theta is 1 negative mu alpha over 2. Right, so let's move this here. Okay, what we can do right now is that we can simplify. Looks like we're at the end of the page. Let's add one more. Again, sine 2 theta is alpha, negative your mu cosine squared theta, which is this. Let's multiply everything by 2. And by this point, it would be wise to make the substitution back. In fact, we can square everything, right? T squared. So be T minimum squared. This will be hold on. Alright, everything's fine. It's fine. Oh, of course. What? Okay, so what we forgot to do is we forgot to spread out the G. Right, so this is actually going to be it's actually going to be T minimum squared. It's going to be 2b over G sine theta cosine theta minus mu g cosine squared theta, which is 2b over g over 2 sine 2 theta negative mu g cos squared theta, which is 2b over g over 2 sine 2 theta is alpha, negative mu g cos squared theta is 1 minus mu alpha over 2. This becomes 4b, multiply everything by 2, this is 2 root b over g root 1 over alpha minus mu plus mu squared alpha, right? So this is going to give us we can factor out alpha, and get alpha back, which is one over root mu squared plus 1. We're really close to the solution here. Lastly, let's rationalize the denominator. Because if you notice, we have a treat that's waiting for us. It's going to be a squared minus b squared, which is simply 1. Here we have it, the expression for T minimum. So for any coefficient of friction on this inclined plane, I get that my minimum time I'll take is 2 root b over g, and this whole expression here. Right, so it's a pretty hard problem in Morin's book. I'll end my video here.